Hi, I'm Mr. Kangas, and today we're going to take a look at Chapter 7, Section 2, representing linear functions. And in this video, we're going to be taking a look at two things. We're going to be looking at how to use linear functions with a table of ordered pairs, and we're going to be looking at how to graph linear equations. So, in this video, in this section, we introduced what a linear function is. It is, when you represent a linear function, you represent it with an equation. This equation is known as a linear equation. You can identify a linear equation because a linear equation will always have two different variables. They'll always be in separate terms. So as you can see, the x and the y, they're in separate terms. They're separated by either a plus sign or an equal sign, a subtraction sign, something like that. And neither variable has a visible exponent because both variables have an exponent of 1. When you have an exponent of 1, you don't write it. It's invisible. So what you can do with a linear function is you can actually find any of the ordered pairs. Linear functions represent lines, straight lines. Lines go on forever in both directions, from left to right. And so if a line is going on forever from left to right, that means it has an infinite amount of points. And each point on the line is represented with an x-coordinate and a y-coordinate on the coordinate plane. So you can actually figure out any of those points that you want. All you have to do is choose some values for your x-coordinates or your inputs, because we input these x-coordinates into our equation and we output the y-coordinates. So for example, if I input 0 into my linear equation, 2 times 0 is 0, plus 3 is 3, so y gets me 3. So one of my ordered pairs, or one of my points on the line that this equation represents, because this equation represents a line, one of the points on that line is 0, 3. So if I had a coordinate grid, I would graph that point. I don't move left to right at all because I have an x-coordinate of 0, and I'd go up 1, 2, 3. That would be one of my points. Now, if I wanted to find another point, I would input the number 1. And the reason why I'm choosing these small numbers is because when you're picking x-coordinates to plug into your equation, you're typically doing that because you're trying to graph the line that your equation represents. Now, there's no point in picking really big numbers, because the bigger the numbers, the bigger your graph is going to have to be. It doesn't matter what 2 points on your line that you pick. As long as you pick 2 points on your line, you can actually create the line. All it takes to make a line is 2 points. So if I plug in a 1, I'd have 2 times 1 is 2, plus 3 is 5. So when I plug in 1, I get an answer of 5. So I'm going to go over 1, up 1, 2, 3, 4, 5. There's my second point. And now I can actually create the line that this equation represents by connecting those 2 points. Some people prefer to do more points than 2. Some people like to do 4 or 5 points, because when you start working with equations that aren't linear, so when you start working with equations that might create curves or waves, using 4 or 5 points gives you a better idea of whether or not you're looking at a curve or a wave. So some other points you may want to pick, and some of the worksheets will actually ask you to pick 4 or 5 points. So some of the other points you may want to pick are points like -1, 2, or even -2. And you always want to go by this rule. If you're going to pick more than 2 points, you want to include 0, 1, and -1 at the very least. These 3 points you almost always want to include, because that'll give you a good idea of what your line, curve, or wave is going to look like. So if we plugged in -1, we'd do 2 times -1 is -2, plus +3, so we're doing -2 plus +3, gets us to +1. So -1, back 1, +1, up 1, right here. And as you can see, the point is right directly on the line that I just drew. So you could go through and do number 2 as well. I'm not going to, but that is how you would graph a linear function or linear equation. You just pick numbers for x, and you get your values for y. Now, some people have asked me, why is it we're always picking and putting in numbers for the x-coordinate? How come we never just pick random numbers for y and then figure out what the x-coordinate is from there? Why are you always plugging in numbers on the left side? The reason why you have to pick x coordinates is because literally every single number you can think of, 99, 10,000, 108.3 million, all of those numbers, every number in existence, will actually have an x-coordinate that represents them. So what I mean by that is the x-coordinates represent the x-axis from left to right. So the black line here that I'm drawing, that represents the x-axis. The x-coordinates move on that x-axis, and if you remember, in order to be a function, you have to always be moving forward. Okay? So in order to be a function, you are always moving forward. So we have waves, okay? We have lines, and we have curves. They're always moving forward. They aren't necessarily always moving up and down, which is the y-coordinates. So if you pick any point on this wave, for example, okay, the x-coordinates, the more points you pick, the further down or the further back you're going on the wave. There isn't a point on the x-axis that I could pick where my wave isn't moving along it. Okay, same thing with my lines, same thing with my curves, because they're always moving forward. However, if I picked a point that had a y-coordinate up here, okay, here is this black line right here, represents y-coordinate 1, 2, 3, 4, 5. So any ordered pair with a y-coordinate of 5 would not appear on my wave. And when you're plugging in x values into this equation, the goal is to get points that appear on your line or your wave or your curve. Now, if I'm plugging in a value of 5 for the y-coordinate, when my wave doesn't even go up 5 high, I'm not going to get a point that's on my wave. It'll be impossible. However, it doesn't matter what point I pick on my for my x-coordinate. That x-coordinate will always appear in at least one point on my wave, my curve, or my line, because my waves, my curves, and my lines are always moving left and right forever and ever, but they're not necessarily moving up and down forever and ever. So like I said, if I picked something, if I plugged in 5 for y for the waves equation, it wouldn't work. But I could plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could plug in 100, and that wave is still moving down the x-axis. It's not moving all the way up the y-axis. It's not moving all the way down the y-axis. So that's why it is you always when you're graphing a linear function, when you're graphing any function, why it is we're inputting for the x coordinates and not the y coordinates. Because again, the lines, curves, and waves don't always travel all the way up and down the y axis, but they do always travel across the x-axis, left and right. That's part of being a function. That's a requirement of being a function, is it has to move forever and ever from left to right. So a curve does the same thing, right? And a line will do the same thing. It'll move forever in both directions, left to right, not necessarily up and down. As you can see with the curve, okay, it doesn't move all the way down the y-axis. A lot of lines will move up and down the y-axis, but there are a couple straight lines that don't necessarily move up and down, in particular horizontal lines. So you want to talk about a linear equation or linear function that will not move all the way up and down the y-axis. It's a straight line. That line is not moving up or down. Okay. That's it on this video. In the next video, we'll be taking a look at solving an equation for y.